All right, we are in part 2 of lesson 3.5, molecular evidence, and we're going to continue talking about how DNA is copied into RNA. So first, this happens in the structure called the nucleus, and the purpose or the function is so that RNA makes a copy of DNA. So to make that copy, we must follow the base pairing rules. And as you can see, we have the DNA nucleotides separated into threes. Now, these three bases at a time, we call these codons. So, to make the copy, let's follow the base pairing rule. What we mean by that is where we see the letter T here, we're going to go to the chart and we're going to see that it pairs up with the letter A. Back to the next base, we're going to see that A in DNA pairs with U in RNA. I'm sorry, yes. And the C in DNA will always pair with G and vice versa. If we continue, that G in DNA pairs with C, so we should have C, C. That third pairs with U. So our RNA codon should be CCU. And this one is super easy because we have the same letter 3 times in a row. That T in DNA always pairs with A in RNA. So we're going to have AAA. Next, we're going to talk about how proteins are assembled. But first, let's talk about what proteins are anyway. Proteins are made of amino acids, and these amino acids are the building blocks of proteins. We're going to constantly ask you that all the time, so please make sure you lock it in your memory bank. Proteins are made of, again, those codons. So each codon codes for a specific amino acid. And proteins are important because they determine your traits. They act as enzymes, which is responsible for your digestive system being good. So when you eat food and your body processes the energy quickly, it is in control of your growth hormones. So from the time you were a baby and now that you're a teenager and one day you're going to be a fabulous adult, it's going to be responsible for how your body changes as you get older. And proteins are also responsible for protecting you because they are antibodies, which protects you when you're sick from viruses and bacteria. So we got out the way what proteins are, but let's talk about how they're made. So we call this step translation. And what we are trying to do is take that DNA strand, make a copy of it in RNA, and then use that copy of RNA to read those bases and see how it will code for the different amino acids. So let's start off with the first step, which is easy because we just did it. We are going to use the DNA strand and we're going to find the complementary base pairs using this chart. So starting with the first nucleotide, which is the letter T, we are going to then find the matching pair. So starting with this first codon, T should be a A in RNA. The A in DNA will be a U, and the C in DNA will go to that G. So our first RNA codon is AUG. We're going to do the same thing for the next one. And we're going to keep pairing, so on and so forth. Where this kind of gets complicated is that on your Regents, they can give you 2 different types of chart to have you figure out the amino acids. And you need to learn how to use both. So let's start off with the easier chart, in my opinion, because it has the exact letters that you need to find. So you're going to start off looking at this side, and I'm going to locate the first letter, which is A, in my first codon. And then it's going to show me AUG. What that represents is the amino acid MET. Now the next one's a little bit more complicated. Again, we're going to look at this row here, and we're going to see that first letter is U. And we're going to roll over so we can figure out where our next letter is G. And an easy way of doing that is by looking at the top. So we have first base is U, second base is G, and then our third base is G. And we know that means that this amino acid is TRP. Next, we're going to have the CCU, and I already did it for you, to be pro. So C, go over to another C, and we have pro here. All right, this is where I'm going to pause the video, and you're going to meet me in part 3 so we can see how our proteins assembled using this type of codon chart, the harder one.